Since this was the first DIY project I ever did and I had really bad tools, but now it's done. Hey ladies and gentlemen, and welcome to this electronics DIY. Are you tired of changing the batteries of your nightlight, or are just cheaply made and break easily? Well, I'm going to teach you how to make this amazing and awesome overkill nightlight. I'm going to teach you how to make it step by step, and I'm going to show you my process. So let's get started. What you're going to need for this DIY is one perf board, one HC SR04 ultrasonic sound sensor, one GL5528 light dependent resistor, 5 220 ohm resistors for the LEDs, one 10 kilo ohm resistor for the LDR, one single pole double throw switch, 2.1 microfarad capacitor, 5 white LEDs, one LM7805 voltage regulator, one 9-volt power supply adapter, and one pair of a male and female power supply socket 2.1 millimeters, and any microcontroller. In this case, I'm using the PIC with the Picket 3 programmer. Now, if you want to use an Arduino, you'll have to figure out the code for yourself, but it'll be essentially the same thing. Now, I'm assuming you have all the necessary equipment such as a soldering iron, but the estimated cost for these items on the screen is $40. Now, I'm going to move on to the schematic, in which I'll explain to you how to wire each component. So in the top left, we have the voltage source, whether this is the power or the voltage from your wall or battery. But in this case, we're going to go straight from the wall using our power supply adapter AC to DC. So that's going to go to our switch, which is then going to turn on or off depending on what we want it to be. On the on state, it's going to go to the LM7805, which is going to regulate our voltage down to 5 volts, which is what we need for our microcontroller and our sound sensor. The two capacitors you see that are directly linked to the LM7805 are known as decoupling capacitors, which will filter out any unwanted rippling voltages that are essential for providing 5 volts exactly to our microcontroller and sound sensor. So now moving along in the schematic, here is the PIC controller labeled with pins 1 through 14. 1 is the ground pin and 14 is the voltage source pin, which we want the 5 volts from the LM7805 to go to. And we also want that 5 volts to go to the sound sensor. Moving along, pin 2 is used as an ADC, which is also known as the analog digital converter, to receive voltage reference from the LDR, which is the light dependent resistor, and the 10k ohm resistor. This is because we want the voltage divider, or the difference of the voltage, and that's how we're going to determine if the room is lit or dark. Now for the sound sensor, pin 3 on the microcontroller is output to the trigger pin of the sound sensor, because we want to send the signal to fire off those frequency waves. Therefore, pin 11 on the microcontroller is set as an input that receives input from the sound sensor's echo pin. This is to let us know when the signal has been received. The red and the black wires are obviously ground and the voltage. Now pins 6, 7, 8, 9, and 10 are just your standard LEDs, which will receive a digital low or digital high. Now here is the ideal placements for the W Nightlight 1. You want to place your device obviously next to a wall socket to provide that constant voltage of 5 volts. Then you want to place your sound sensor near the opening of your door, as you can see in the diagram. And you want to place your LEDs anywhere actually, but do not place the LEDs extremely close to the device, because the light dependent resistor may pick it up as being the room fully lit, but the light dependent resistor is just going to pick up the room which is ambiently lit. Similarly, make sure the line of sight for the sound sensor's receiver and transmitter are not going to be blocked by any obstacles. The line of sight for the sound sensor must be clear, and I will explain more of that when we look at the code. and how the logic works with this project. With that said, let's jump right into the building process. Initially, I was going to use a infrared distance sensor, but that ultimately changed to using the ultrasonic sound sensor for more practicalities. Alright guys, so look here. Here we have a PIC 16324 microcontroller, and it's on a development board that I had for one of my classes, and we're just programming it to make this. What do we call it? Automatic night light or whatever. So here we have an IR sensor by OSAP. These are Arduino compatible, and what they have is the ground, voltage, and the signal. And the signal is in digital actually, and you have to set the distance with this potentiometer and the frequency to whatever you want. And as you can see, it'll probably only send 1 or 0, high or low, and that's being fed here. Now for some reason I couldn't just read the value directly as a digital pin, so I just use an analog to digital converter, and it works fine. And here we have a light dependent resistor. So right now you see there's nothing happening because there's light in my room. But anyways, what I have it set up here is it's connected to another analog to digital converter in my code, and then it'll only turn on this LED right here if someone passed by and it's within the distance and the room is dark. So I'll show you right now. So I have my finger in front of here and it's dark and the LED turns on. Why do I have it that way? Because let's say it's dark but there's no one in the room, no one's in the restroom. You don't want the LED to turn on. And let's say someone walked by but they turned on the lights in the bathroom. You don't want the LED to turn on. But what if someone walks by and there's a specified time interval, someone walks by and the bathroom lights are off, then the LED will turn on. Okay, so you're probably wondering how are you feeding this? Well, this is very simple. For the light detector resistor, it's just being sampled by voltage divider rule, and we're reading that from our ADC, which is the analog digital converter. So the PIC is running off of 5 volts. So I don't know if you can see the multimeter. I don't know if you can see that. It's around 2.8 volts. And the photoresistor right now with this ambient light is at 2.14. So we're varying from 2.14 and 2.8, and that's a step of probably 0.4, 0.5 volts. That's pretty high, and it's not going to be precise. But let's see how many volts goes through. So the voltage increased because the resistance is lower because it's dark, and it went up to 3.3. It's oscillating because of the light, obviously. So it's 3.2. So in the code, I just have it set as for whatever value, and you have to experiment. It's trial and error. If you have a different resistor and a different light dependent resistor, you're gonna have to just use voltage divider rule with your voltage source to find out what a good stepping value is for your ADC. And it's also dependent on your microcontroller. Like this microcontroller can only go up to 255 because it's 8 bits. So yeah, you have to figure that out. Just read the datasheet. But if you're using an Arduino, you don't need to worry about that because they go up to 16 bits, 32 bits or something. Okay. So now that we have this circuit working, I'm actually going to add more LEDs because one LED is not enough to light up a room. So I'm going to be adding more LEDs to these pins, and then probably I'm going to add a switch to turn on this entire circuit because we're going to run it off 9 volts. But we can't directly run this microcontroller off 9 volts. It's going to burn out. It only goes up to, I think, 6 or 5 volts. So, well, ignore this other stuff. I'm going to use a voltage regulator with decoupling capacitors to to just regulate the voltage down from 9 volts to 5 volts, which will be perfect for the system. And I'm going to solder this onto a perf board or whatever PCB board, like this really cheap one. What we got here? This really cheap PCB board. And that's it for this. So I made some progress on the soldering, and here we have the battery attached, and this is what it looks like close up. It's not that bad. There's a voltage regulator, and this board or these PCBs kind of suck because you have to solder on both sides unless you solder everything on the bottom like I did. And I just made one side dedicated to ground. Yeah, this entire side is dedicated to ground. So where you see black is ground, and where you see red is voltage, just so I can have an easier time soldering. Alright, so we're going to test it. It turns on with the middle switch. There we go. And from ground, from the source, it should show 9 volts, or at least close to 9 volts. So there we go. We're getting it at almost 9 volts, but I've been using this battery. Can you see? Yeah, so I'm probing up here. This is the source from the switch, and this is ground. So it's about 9 volts. And then it goes to the voltage regulator, and we should get out at least 5 volts. So 4.99. It's pretty close. Probably because of the ceramic capacitor I have on here, and the other one is film or whatever, a film resistor. I mean, capacitor, blah. That's okay. So I'm just going to keep soldering and finishing this up, and then I'm going to add some headers here for the sound sensor and the light dependent resistor, and I'm going to set it up in my bathroom. Don't worry, it works. I already tested it. So what I added, here's the light dependent resistor right here, and it's being voltage divided by this resistor, which is 10 kilo ohms, and this goes from 10 to 20 kilo ohms, so it's good. And that gets fed into this pin. I know it's like so ugly, but that's okay as long as it works. I hope I can get better equipment though. So at this point in the project, I decided to switch the infrared distance sensor to using an ultrasonic sound sensor instead. SR04 ultrasonic sound sensor, but I don't have anything except from that one project I made last year, the sound vortex controller. So what I'm going to do is I'm just going to measure it out, cut it out. Alright, it's time for the fun part, the code. I'm going to briefly explain this in a simple manner, so let's go. At the start program, we're basically initializing everything like our ADC and checking the LEDs by turning them on and off. Then we're enabling all the necessary timers, which are going to be used for this device and the ultrasonic sound sensor, which has 2 timers. In the main while loop, everything is considered off and we are constantly calculating the distance. Now, if someone were to walk by and pass through our parameters of the distance and the room is dark, we will turn on the lights and we'll set a Boolean expression, in this case the variable inside outside bool, to 1, which is true. Now we move on to the second while loop, and this is when we know someone's inside the room. If someone leaves the room or turns on the light, then we're going to turn off our LEDs. Or if someone leaves the room and it's dark, then we're still gonna turn off the LEDs because no one's in there. Or what happens if someone left the room but our sound sensor didn't pick it up and the lights are off? Well, after around 5 or 6 minutes, we're gonna turn the lights off anyway. And that's basically how this code works. You can go to the article on my website if you want to learn more about it. Alright, here is the final product. I just used a generic box and crafted it to fit my device. As you can see, I also added Velcro straps so it can stick onto the wall. Now that's done. To finish it off, just upload the code to the microcontroller, pop it into the headers, wire everything up, and you're good to go. Alright, that's the doorway. But it's dark, I know. So I'll use a flashlight. Alright. So when I walk, it's gonna turn on. Check this out, boys. It turns off. Let me turn on the lights. See, it doesn't turn off. The lights are off. But if you put your hand. Since this was the first DIY project I ever did and I had really bad tools, but now it's done. So when you walk in, it's gonna turn on, and there's actually 3 conditions for the lights to turn off. Is 1, if you turn on the lights will turn off. 2, when you leave the room, it'll turn off. And 3, if the sensor didn't pick you up leaving the room, it'll turn off automatically after 3. I think I put it for 5 minutes, and that's based off a timer. So let me go inside the bathroom, and it's gonna turn on. But it doesn't have to be a bathroom, you can use any room. See, there we go, turn on. And my camera person is standing in between, so it's going to stay on, but then it's going to turn off. So here's the sound sensor, the ultrasonic sound sensor, obviously. And the unit is underneath here. Let me turn on the lights. The unit is underneath here, as you can see right here. Right there, see? And we have 5 LEDs. You don't have to use these kind of LEDs, you can use any kind of LED. So just check out the article for the schematic and the code. Thanks for watching.